Another group of compounds which are considered as the acid derivatives, although they do not have a carbonyl functional group, are the nitriles. So the nitriles, as we know, that there is an R, which is an alkyl or aryl group, and then C triple bond N. Here, there is no carbonyl group, but the nitrile are considered as I said, as one of the derivatives of the acids because they come from the acid and we can hydrolyze them to give acids as well. So the carbon here, because it has triple bond, it's an sp hybridized, and the nitrogen is also sp hybridized. The lone pair of electron of the nitrogen are not available to act as Lewis base, so they are very, very weak base like amides, unlike amines. And because the lone pair here are tightly held by the nitrogen, so they are not available for basicity. The how to name nitrile. There are two ways to name nitrile. The first way is to use the alkane name and then add a nitrile. Always remember that the carbon of the nitrile group is considered to be the carbon number 1 of the parent name of the alkane. So let's have a look at this one. So if we start with 1, 2, 3, 4, 5, 6. Remember, I counted the carbon of the nitrile functional group. So this is going to be hexane nitrile. I don't need to say 1 for the nitrile because we know that this is the main functional group where it's been given the parent name. So it's hexane nitrile. And then I need to look at the different substituents, which are the PR here, bromide on carbon number 5. So it's going to be called 5-bromohexane nitrile. Another example here, so this is cyclohexyl group. Okay, so the parent, now my parent alkane is the one with only one carbon, this one. I'm not going to call this methane nitrile, but we call it carbonitrile. So we call this carbonitrile, and I consider the cyclohexane as a substituent or as a part of my structure. So I call this cyclohexane carbonitrile. I'm not gonna call it any other way because I cannot include the cyclohexane with the carbon in one name. So it's called cyclohexane carbonitrile. I don't again need to say where the position of the carbonitrile because it's the only substituent and it's going to be on the carbon number 1 of the cyclohexane. Another common name, the common name for naming nitrile is it comes from the carboxylic acid. We replace ic with of acid with O nitrile. So we can say hexanonitrile rather than hexane nitrile. So this is like the common name. Acid halides, as we said, we replace the OH of the carboxylic acid with halide. The most common one we usually encounter in organic chemistry is the chloride. So the acid chlorides are the most common acid halides. There are acid bromides as well, but the most common one is the acid chloride. Acid chlorides are more reactive than the acids themselves. This is because the halogen here can withdraw the electron density from the carbonyl group. So if the chloride can withdraw the electron density this way, that means that this carbon can have even higher positive charge, so it will be very reactive. How would we name the acid halides? We name it by replacing the suffix "ic" for the ic acid, with "yl" halide. So, for example, this is benzoic acid. So, benzoic acid is this acid, C double bond O, OH. When we replace this OH with Cl, it becomes benzoyl chloride. So, I replaced, so it's benzoic acid. So I replaced the ic acid with yl halide, so benzoyl chloride. This one, let's have a look at this one now. So where is our acid? Our acid is this one. So it's 1, 2, 3, 4. So it's butanoic acid. So the parent acid here is butanoic acid, and the butanoic acid has one substituent on carbon number 3, which is the bromo. So it's a 3-bromo. Then instead of saying butanoic, I will say, or we can say it butanoic, or we can say butyric acid. So we can say butanyl bromide, or we can say butyryl bromide. This is as a common name. If you notice here that in this name they said beta bromo butyryl bromide. So beta, because in carboxylic acids and carboxylic acid derivatives there is a different way, which is a common way. It's not the IUPAC name or not the IUPAC system, where we can give letters to the carbon attached to the carbonyl carbon. So the first carbon next to the carbonyl carbon is called alpha. The second one is called beta. The third one is called gamma. So I can, if I have a substituent on this carbon, which is the carbon number 2 for the carboxylic acid, which is the carbon just adjacent to the carbonyl carbon, I can say alpha and then the name of the substituents. Here, because I have the substituent, the bromo substituent on the second carbon, not the first carbon attached to the carbonyl, so I can call it beta bromo. So this is why I call it beta bromo. I give it the letter beta rather than the letter alpha, rather than the number 3. But the AUPAC system, I have to give it the number 3. What about acid anhydrides? So we said that acid anhydrides come from replacing the OH with a carboxylate group, alkyl carboxylate group. So how we form acid anhydride? Acid anhydrides basically come from the name acid anhydride. Anhydride means remove water. So if you have two acids together and you removed water from these two acids and combine them together will give you the acid anhydride. So you have acid number 1 and acid number 2, remove an OH from one and a hydrogen from the other, and then make a bond between this carbonyl carbon and this oxygen, you will end up with the acid anhydride. Acid anhydrides again are very reactive. They are more reactive than the acids themselves, but they are less reactive than the acid chlorides. How would we name anhydride? So in hydride, we replace the word acid with the word anhydride. But we usually do this if we have both acids are identical. So here, this acid here, so we have the two acids here are identical, so both are ethanoic acid. So we can call this ethanoic anhydride straight away, or a common name, acetic anhydride, because this is acetic acid and this comes from acetic acid. So basically acetic acid is this one. So if you combine two acetic acids together, remove the water, you're gonna end up with the acetic anhydride, or if you're gonna call it the IUPAC system, it's going to be ethanoic anhydride. But we can have also a mixture of two acids that form the anhydride. In this case, we're not going to say acetic anhydride or ethanoic anhydride. We have to say both acids. So for example, in this case, we have two acids. We have ethanoic acid coming from here, and we have propanoic acid coming from there. So this is going to be called ethanoic propanoic anhydride. So when you say only one acid name, that means both derivatives of the acids on the anhydride are identical, and this is the one. We don't say diacetic anhydride, we just say acetic anhydride. We don't say diethanoic anhydride, we just say ethanoic anhydride, and that means that both sides of the anhydride are ethanoic acid. But when we have a mixture like this one, we have to name both of them and we arrange them alphabetically again. So ethanoic propanoic anhydride, or we can say acetic propanoic anhydride. propionic anhydride. This is the common name. So acetic acid and propionic acid. So it's acetic propionic anhydride. This one we have two. We have ethanoic acid and have butanoic acid. This is 4 carbons. So it's going to be butanoic ethanoic anhydride. We started with butanoic because because it's B, and then ethanoic because we have to arrange them in alphabetical order. To say it in more common name, so it's acetic butyric anhydride. This is called butyric acid. So this one is called butyric acid, and this is called the acetic acid. So this is going to be acetic butyric anhydride.